Hello everyone. In this video clip, I'm going to give you a review on inequalities on polynomials functions and rational function. And then I'll give you a review about the absolute values. Okay, so let's start with the first part, inequalities. Okay, let's start the session with an example. Very easy one, simple one. Solve for x. I got x minus 3 to be greater than 0. Very simple. Okay? So you only do one little step to get the answer. Add the 3 on both sides. You got x minus 3 greater than 0, so add 3 on both sides. Somehow we write it. So add 3 on both sides. We got x is greater than 3. Okay? The main point, this one is not about solving this. Obviously, I know that everyone can solve it. I want to introduce to you guys something called the sign table. It's going to help you to solve a bigger problem. Okay? The sign table is this. For this particular problem, all right, we're looking for the sign of that linear term. It's x, then x minus 3. We know that x equal to 3, x minus 3 will be equal to 0. By the way, x equal to 3 equal to 0 of this linear term. X equal to 3, x minus 3 will be equal to 0. Okay. What happens when x is bigger than 3? Say x equal to 4 or 5 or 6. You plug in here, plug in the number that's bigger than 3, say 4, 4 minus 3 is positive. So when x is bigger than 3 all the way to infinity, the x minus 3 will be a positive number. Similarly, if you plug in something less than 3, all the way to negative infinity, the sign of x minus 3 will be a negative number. And the whole thing that you guys see right here is called a sign table. And this tells you what? When x equal to 3, that term is 0. When x is bigger than 3, that x minus 3 term will be a positive number. When x is less than 3, the x minus 3 will be a negative number. With that sign table, you'll be able to answer any kind of question they ask. Okay? If they ask what? Find all the value of x such that x minus 3 positive, strictly positive. This side, positive. So the answer will be greater than 3. X greater than 3. And the interval notation for this will be parenthesis 3 to infinity. Okay? What if I change the question? Instead of greater than strictly, what if I put it this way? Greater than or equal to. And that means what? X could be positive or equal to 0. And according to the question right here, the answer will be x is greater than or equal to 3. We square bracket 3 to infinity. Right? This is for greater than or equal to 0. This is for greater than 0 only. What if my question is x minus 3 to be less than 0? If the question is about less than 0, now you don't look at the positive sign anymore. You look at the negative sign, strictly less than 0. So we don't count 3 in here. We don't count 0 in here. So what? X is going to be less than 3. Of course, the answer is going to be what? Negative infinity all the way to 3. And similarly, less than or equal to 0. The answer will be x less than or equal to 3, which is negative infinity all the way to 3. But this time I use square bracket. Okay, now let's move on to a little bit harder example. What if I ask you to solve for x this way? X squared minus 4x plus 3 to be greater than 0. Okay? Now it's not easy to solve for x in here. Actually, it's not really possible to solve for x from here. Okay, so you don't subtract 3 on both sides, that would not work. Instead, you're gonna factor the left hand side out. And keep in mind that solving this type of problem, you try to bring everything to one side and then 0 on the other side. Okay, always 0 on one side and then the other side is everything. Okay, keep in mind. Now what if you see the problem like this? X squared plus 3 greater than 4x. You don't start solving from here. You know what to do? Subtract the 4x on both sides. then bring it back to the problem. Everything in one side, 0 on the other side, okay? Now, the second step is we try to factor out. You see what we have in here? This is a quadratic equation. So what? This is x minus 1 times x minus 3 to be greater than 0, okay? What you see in here? We have a product of two linear factors. And I'm going to apply the sine table one more time to solve this problem. This time, instead of having just one linear factor, I have two, but the idea is the same. So my table is a little bit bigger. Okay, I have two zeros in here. X equal to 1 is the zero critical value for the first factor. X equal to 3 is going to be the second zero. Okay, and I'm going to arrange the zeros, the x values from smaller to bigger. So 1 here, 3 there, this way all the way to negative infinity, all the way to positive infinity. Okay? Now let's talk about the first factor, x minus 1. Obviously, x equal to 1 is something 0. What if x is bigger than 1? Bigger than 1, then it's going to be positive. Less than 1, it will be negative. The second factor is x minus 3. 0 is at x equal to 3. Right? X equal to 3. X minus 3 means 3 minus 3, 0. Bigger than 3, positive. Less than 3, negative. Okay. Now I'm going to multiply the two factors together to get our quadratic. X minus 1 times x minus 3. And the sine table will tell you what? When x is less than 1, say 0, negative 1, negative 2, the first factor will be a negative number. The second factor will also be a negative number. What if you multiply a negative number to a negative number? What's you going to get? Negative times negative is a positive number. Okay? We move on. When x equal to 1, the first factor is 0. The second factor is something. And you multiply together, 0 times something is 0. Similarly, with x between 1 and 3, then positive times negative is negative. X equal to 3, something times 0 is 0. X is bigger than 3, positive times positive is positive. Now you got a sine table. Depends on what they ask in the question, then you're going to look at the table and you're going to get the appropriate answer. Okay, so in this particular question, I asked you what? X squared minus 4x plus 3 to be positive, greater than 0. Okay, so let me erase this. Have some room to write. For the greater than 0 part, we're looking for the interval, the part that got product positive. I got what? From negative infinity to 1, strictly positive, yes? And then what? 3 to infinity, okay? We're gonna combine those two using union. Either x in this or x in that. What if the question is greater than or equal to 0? Then we don't just count for the positive, we include a 0 in here. So negative infinity to 1 with square bracket and then union. Oh, this one gonna be square bracket again. 3 to infinity. Okay? Similarly, what if the question is less than 0? Negative, strictly less than 0. Negative is right here, so it's gonna be between 1 and 3. 1 comma 3 in parentheses. But if it's less than or equal to 0, and what we count 0 as part of the solution, so 1 comma 3 in square brackets, the closed interval. Okay? And with this method, using the sine table, you guys can solve all kind of problems involving polynomials functions. Okay? Not just polynomial function, because polynomial function only deal with what? Multiplication. It's also work with division as well. When you have a factor divided by a factor, you have something called the rational function. Let me show you another example of this. Okay. To save time, let me try to factor out everything for you. Solve for x, okay? I'm having this. X minus 1 times x plus 4 over x plus 2 to be positive. What we're seeing here is we have three linear factors, x minus 1, x plus 4 on the numerator, and x plus 2 on the denominator. So we have three zeros, x equal to 1, x equal to negative 4, and x equal to negative 2. 1 is for this factor, negative 4 is for the second factor, and negative 2 for the denominator factor. Okay? The question is find all the values of x such that this fraction on the left hand side to be positive. Okay? And I'm going to use the same method. I'm going to construct a sign table one more time. Okay, this time my sign table is going to be even bigger than the previous one. X, I have three values. Okay, well, we have to arrange it in the increasing order. So smallest first, negative 4, and then negative 2, and then 1, so all the way to positive infinity. Well, this is all the way to negative infinity. Okay, and we're going to take care of one factor at a time. How about x minus 1 first? The 0 here is x equal to 1. X bigger than 1, positive. Less than 1, negative. Second factor, x plus 4. Doesn't matter which order you write, you can just write one factor at a time, okay? And the 0 for this is negative 4. Bigger than negative 4, positive. Smaller than negative 4, negative. And then x plus 2. The 0 here is at negative 2. Okay. Bigger than negative 2, positive. Smaller than negative 2, negative. Now what we're doing to get to the answer, we take what? X minus 1 times x plus 4, and then everything divided by x plus 2. Alright? So, using the table, when the value of x is less than negative 4, the first factor is negative, the second factor is negative, the third factor is negative. What do? Negative times negative divided by negative. Negative times negative positive divided by negative is negative. Okay? X equal to negative 4. We have something times 0, which is 0, divided by something. 0 divided by something is 0. Oh, I was wrong. This is going to be 0 right here. Apologize. When x is somewhere between negative 4 to negative 2, say negative 3, negative 3.5, something like that, we have negative times positive divided by negative. Negative times positive is negative, divided by negative, we have a positive number. Okay? Now, here comes the interesting thing. X equal to negative 2, we got what? Something times something, which is something, and then divided by 0. What happened when we divide by 0? The answer is undefined, and this is how we denote undefined. 2 bars like that means what? We don't have a number coming out. Okay? Undefined. And now, similarly, when x is negative 2 and 1, negative times positive is negative, divided by positive is negative. X equal to 1, 0 times something is 0, divided by something is still 0. Right? You multiply by 0 is okay, but divide by 0 is not. Positive, positive, every positive, so this is positive. And now you have the sign table. Whatever question they ask, you can answer. Okay? In this particular question, they ask you what? Positive, right? To be greater than 0. If it's greater than 0, your answer will be 2 intervals. From here. Negative 4 to negative 2, but not 0. This is undefined. And what? Bigger than 1. The answer is negative 4 to negative 2, union 1 to infinity. Okay. What if the question is greater than or equal to 0? Now we look at the table, we don't just count the part for positive, we also count for the parts equal to 0. So the answer will be negative 4 comma negative 2, parenthesis, because there's no 0 right here. Okay? And then union square bracket 1 to infinity. What if we have less than 0? Then it's going to be negative infinity to negative 4, union from negative 2 to 1. I'm looking at a table. Then less than or equal to 0, I got negative infinity to negative 4 bracket. union was negative 2, I still have parentheses and then 1 square bracket, okay? Because no value right here. For negative infinity to negative 4, okay, including 0 right here. And then negative 2 to 1, not including negative 2, but including 1, parentheses, bracket, okay? And this is the first part of Appendix 8. Hopefully the examples I'm giving you that help you to solve your homework problems. Now let me talk about the second item, the absolute values, okay? It is a review, so hopefully you can recall this material that you learned before. Okay. It's absolute value. So let's start with definition, all right? We did know absolute value this way. Value of x in between. And this, by definition, this is the distance from the origin to x on the number line. So graphically, say if you have a number line, 0 right here, so if x is a number right there, then how far is it from the origin? This is absolute value of x. This is the distance, that's the key. Okay? Doesn't matter where x is on the number line. X is on the negative sign right there. The distance still from here to here, excuse me. Okay? This is absolute value, the distance. Okay? So, what if x equal to 5? The absolute value of 5 is the distance from 0 to 5, which is 5. What if x equal to negative 3? The distance, this is negative 3. Okay? Distance from negative 3 to 0 is 3. Okay? So distance will always be a non-negative number. What about absolute value of 0? Is 0, because the distance from 0 to itself is 0. Sounds good? So, keep it here for a minute. In general, if x is a positive number, okay, on this side, x is positive number, the absolute value of x is just x itself. The absolute value of 5 is 5. If x is a negative number, the absolute value of x is going to be negative x. Now, don't misunderstand negative the negative sign going to give you a negative number. No. Because x itself is a negative number. So x is a negative 3, right? So I put a negative sign in front of negative number, it's going to give you a positive number. That's all. Okay. Now let's talk about solving the equation involving absolute value. Say you have solve for x, easy one. Absolute value of x equal to 5. What x could be? Then we actually have two values, the absolute value of x equal to 5, which is x equal to 5, right? But that's not the only solution. We have another one. The distance from 5 to 0 is 5. Another one, which is x equal to negative 5. Okay? This notation means what? Find all the value of x and set the distance from the x to the origin equal to 5. You have this. Make the problem a little bit more complicated. What if we have this? Absolute value of x minus 3 equal to 5. Now the number inside the absolute value is not x anymore. It is x minus 3. So we split it up into two cases like this. We have what? X minus 3 equal to 5, or x minus 3 equal to negative 5. Because the number now is x minus 3. The distance from this to origin is 5. Or distance from x minus 3 to 0 is negative 5. We can solve x from here. And we also have two solutions. X equal to 8. Or here, x equal to negative 2. I've just added 3 on both sides. I have this. See? Check it out. 8 minus 3, yes, 5. Good. Oh, negative 2. Negative 2 minus 3 is negative 5. The absolute value is still 5. So it doesn't matter what, excuse me, whenever you have absolute value equal to a number, you split it up into two cases, and you can solve. All right? Now, let's talk about inequalities. We have two types of inequality. absolute value of x is less than 5. And what do we mean by this? This is the origin, okay? We look at all the number of x such that the distance from x to the origin, by definition, is less than 5. 5 is right here, negative 5 is right here, so the distance less than 5, so x could be anywhere from here to here, okay? So in this strict less than 5, we don't count 5, we don't count negative 5. So what? Negative 5 will be less than x will be less than 5, that will be our solution. For the interval notation, going to be this. And of course, if I put less than or equal to, then it's going to be square bracket. Okay? X could be anywhere in here. Then the distance from x to origin is going to be less than 5. Are we good? And then we're going to extend the concept a little bit more. What if we don't have x? Instead, we have to say x minus 3 to be less than 5. We apply the same idea. All right? We have x minus 3 to be somewhere between negative 5 to 5. Okay? Don't try to add the 3 first. You have to put the x minus 3, the whole thing in between the two values, 5 and negative 5, before we solve x. Okay? And we add 3 both sides, and 3 sides we have. Negative 2 less than x less than 8. That will be your answer. Which is parenthesis. Okay? Good? And the second type of inequality is greater than. Okay? So let me change that. This is, say, greater than 5. Where can x be? X is going to be either right here, and the distance from x to origin is going to be greater than 5. Or x will be on this side as well, and greater than 5, because x is negative 6 or negative 7. The distance also greater than 5. Now that we have two inequalities separately,